Today is our final day of solving trigonometric equations. You need to be prepared to take a quiz next class over this stuff. The main thing that I need you guys to pay attention to and understand, the mistake I'm seeing you do the most is this one right here. It says, do not make the mistake of dividing each side of the equation by a trig function. When you do this, you lose solutions. So please, when you are solving algebraically, never divide both sides by tangent or secant squared or sine. You have to add or subtract or multiply, but you cannot divide both sides. Your goal when solving a trig equation is to use an identity, if needed, to get your equation into one trig term that is factored. Once it's factored, you can actually solve. So in example A, we are going to change the sine of 2x to 2 sine of x cos of x. So here I have two different trig functions, but if I factor out a cosine, then I'm left with 2 sine of x plus 1. So I have in my individual factors, I have cosine in this factor and sine in this factor. That's legal. So now I'm going to set each factor equal to 0. And I can solve. So here I get sine of x equals, if I subtract 1 and divide by 2, I get sine of x equals negative 1/2 and cosine of x equals 0, and I can go to my unit circle to find my final answers. So my final answer here is going to be x equals pi over 2 and 3/2 pi. And for this one, I'm running out of room, and I didn't move my screen up, sorry. I'm going to get x equals 7/6 pi and 11/6 pi. So I only have those four answers because my directions say solve the equation on the interval 0 to 2 pi. So when I have this, I do not include the plus 2 n pi in my answer, or the plus n pi in my answer. That's how the directions will be on your quiz. On example B, even though I only have cosine in my problem, I want to replace the cosine of 2x with a double angle formula. In this case, I am going to use 2 cosine squared of x minus 1, and then I'll drop down the plus cosine of x plus 1. The reason why I'm using the 2 cosine squared of x minus 1 as opposed to one of the other two choices is because now my entire problem is in terms of cosine. I can combine like terms and those cancel out. So I'm left with 2 cosine squared of x plus cosine of x equals 0, and I can factor out a cosine. You usually use an identity one time in trig equations, and then after that, the rest is just some sort of algebra. I'm left with 2 cosine of x plus 1 equals 0. So I set cosine of x equal to 0 and 2 cosine of x plus 1 equal to 0. If I solve for cosine here, I subtract 1 and divide by 2. I know that cosine, or the x value on the unit circle, is equal to 0 at pi over 2 and at 3/2 pi. And the x value is equal to negative 1/2 on the unit circle at 2/3 pi and 4/3 pi. This next problem is something we haven't seen quite yet. If you look at it, it has an x and it has a 2x. So the angles are different. What that means is that we are going to have to let our formula that we use have two different angles. So if I let alpha be x and beta be 2 of x, if I look at the way this is set up, it's sine cosine plus cosine sine. That is the same setup as our sum formula for sine. So I am going to condense this whole thing to be the sine of alpha, which is x, plus beta, which is 2x, and keep it equal to radical 2 over 2. Now I can follow order of operations and do what's inside the parentheses. So I get the sine of 3x equals radical 2 over 2. And this is similar to what you had in the last set of notes, where now you have a multiple angle, so you're going to get multiple answers. If there's a multiple in front of your angle, you ignore it for now, and you ask yourself, where is x equal to radical 2 over 2? And I know that x equals radical 2 over 2 at pi over 4, but in this problem, I have to put a 3 right there. Anytime you put a multiple in front of the angle, you have to add 2 pi to your answer so that you can get multiple answers. I also know that 3x is equal to 3/4 pi because the y value is radical 2 over 2 at 3/4 pi also. Since I have a number in front of the x, I have to add 2 pi so that I can get my multiple answers. My next step is to solve for x. So I'm going to divide everything by 3. I'm also going to divide everything by 3 over here. The 3's cancel, and it gives me x equals, the numerator never changes. To get the denominator, you just multiply 4 times 3, and then we're going to add 2/3 pi to that. So I know one of my answers is pi over 12. So I'm going to list my answers over here. I know pi over 12 is an answer, but I'm going to have to add to that. What do I add to that? Well, I need to add 2/3 pi. Well, if I add 2/3 pi, then I know when I add fractions, I need common denominators. So I need to multiply this by 4, and adding 2/3 pi is the same thing as adding 8 pi over 12. So I'm going to come up here, and I'm going to add 8 pi over 12 to pi over 12. So I come up here to my answers, and I'm going to take pi over 12 plus 8 pi over 12 to get my second answer. And that's going to be 9 pi over 12. Well, 9 pi over 12 reduces to 3/4 pi. Then if I add 8/12 pi again to 9/12 pi, that gives me 17/12 pi. If I add 8/12 pi to that, that gives me 25/12 pi. The problem with 25/12 is that it is more than 2 pi, and our directions say that we cannot go over 2 pi. So I can't include that. Those 3 answers are the only 3 answers, 3 multiple answers that go with the first part of my equation. So now I have to go to the next part. When I divide by 3, so now when we divide this equation by 3, that leaves us with x equals 3 pi over 12, because the numerator stays, you multiply those two denominators. And then since our denominator is 12, we are going to actually add 8 pi over 12, because that's equivalent to 2/3. Now you can reduce 3 pi over 12 to pi over 4, but a lot of times I'll just leave it in terms of twelfths, because that way you're adding fractions with common denominators. So now I need to add that to my list of answers. So in my list of answers, I can either put 3/12 pi or pi over 4. When I add 8/12 to that, I get 11/12 pi. When I add 8/12 to that, I get 19/12 pi. And when I add 8/12 to that, I get 27/12 pi. And that's over 2 pi, so that's too big. So my final answers end up being these 3 and these 3. When I have a number in front of the x, it's a multiple angle, so I get multiple answers. I was having some issues with my notes, so I had to go to a whiteboard, but this problem is the same as your example D. Above example D, there's a new set of directions that we haven't worked with yet, and it says sometimes you must square each side of an equation to obtain a quadratic. When you do this, you can introduce extraneous or extra solutions, and you need to check your answers to make sure they really work or some of them don't work. So the reason why I have to square both sides on this problem is because I can't replace sine with anything except for 1 over cosecant or cosine with anything except for 1 over secant, and that's not going to get me anywhere. So if I square both sides, then I get sine of x plus cosine of x times sine of x plus cosine of x equals 1. I need to FOIL this, and when I FOIL this, I get sine squared of x plus 2 sine of x cos of x plus cosine squared of x equals 1. I know that sine squared plus cosine squared is equal to 1, and I'm going to leave the 2 sine of x cos of x alone because I like to change one thing at a time. And I can also see now that if I set this equal to 0, then I get 2 sine of x cos of x equals 0 because the 1's cancel. This is already factored. If we put the 2 in parentheses, the sine of x in parentheses, and the cosine of x in parentheses, I have 3 different terms. Dividing both sides by 2 will cancel that 2 out. So now I have sine of x as a factor times cosine of x as a factor equals 0. So I need to set each factor equal to 0 and go to my unit circle and find my solutions. I know that sine is equal to 0 at 0 and pi. Remember, I cannot include 2 pi in any of my answers, so that's why I did not do that on that one. And cosine's equal to 0 at pi over 2 and at 3/2 pi. All 4 of those might be answers. 3 of them, 2 of them, 1 of them, or maybe none of them are answers. When we square both sides, we have to check our answers in the original problem. So let's do that. My original problem was sine of x plus cosine of x equals -1. So I'm going to plug in 0. Well, I know that the sine of 0 is 0, the cosine of 0 is 1, and that does not equal -1. So that means 0 doesn't work. Now I need to plug in pi. The sine of pi plus the cosine of pi, does that equal -1? Well, the sine of pi is 0, the cosine of pi is -1, and 0 plus -1 works. So pi is one of our solutions. Now I got to plug in pi over 2. And the sine of pi over 2 is 1, the cosine of pi over 2 is 0, and that does not equal -1, so pi over 2 gets crossed out. It does not work out. Has to be a true statement to keep it a solution. So the last one is 3/2 pi. So I'm going to plug in the sine of 3/2 pi plus the cosine of 3/2 pi, and that does equal -1. So we have 2 solutions in this problem. Our final solutions for x are pi and 3 pi over 2. Those are the only 2 out of the 4 that work. I'm going to have to do this one more time with example E. I'm going to square both sides. The only time I really want to square both sides is when I have tangent and secant and they're not squared. They're not double angles. They're not half angles. I can't use any of my formulas here. When I square this, I'm going to have to write this out twice and FOIL. Now, some of you can FOIL without writing it out twice, and that's fine too. Which gives me tangent squared of x plus 2 tangent of x secant of x plus secant squared of x equals 1. Now what I did on this one, which is a little different from the last one, is I actually subtracted 1 first and set this equal to 0. The reason why I did that is because I know that secant squared minus 1 can turn into tangent squared. So now I have tangent squared of x plus 2 tan of x sec of x plus tangent squared of x, which gives me like terms. So I have tangent squared plus tangent squared, which is 2 tangent squared. And now I can factor. So each problem's a little different. You just have to look at the algebra that needs to be done. I can factor out a 2 tan of x, which leaves me with tan of x plus secant of x equals 0. Once it's factored, you can set each factor equal to 0. So I get 2 tan of x equals 0, divide by 2, and tangent of x equals 0 at 0 and at pi. So we got to check to see which one of those works. Now, when I set this one equal to 0, tangent plus secant equals 0, that's going to be very similar to my original problem. And I'm going to have to use some identities here. So if I change tangent to sine of x over cosine of x and secant to 1 over cosine, then I have a common denominator. When I have a common denominator, I want to write it as one big fraction. And then we haven't done this step for a while, but I'm going to put 0 over 1 right here. Let me change colors so you can see this a little bit better. I'm going to put 0 over 1 right here, and I'm going to actually cross multiply. I can cross multiply, I just cannot divide both sides by a trig equation. So then that gives me cosine of x times 0, which is 0, and sine of x plus 1 times 1, which is sine of x plus 1. So then sine equals negative 1, and that happens at 3/2 pi. So I'm looking to check 3 answers right now and figure out which ones work. So again, you have to check in your original problem. So you're going to do the tangent of 0 plus the secant of 0 and see if that equals 1. Well, the tangent of 0 is 0. The secant of 0 is 1, so that does equal 1. 0 works. That is one of our solutions. Then we do the tangent of pi plus the secant of pi and see if that equals 1. The tangent of pi is 0. The secant of pi is negative 1, so that does not equal positive 1, so that one does not work. We cross it out. And the last one to check is 3/2 pi. So we do the tangent of 3/2 pi plus the secant of 3/2 pi, and that does not equal 1 either because the tangent of 3/2 pi is undefined. So this one doesn't work. So we only have solutions, one solution actually. We know that x equals 0 because 3/2 pi gets crossed out too. Email me if you have questions. Bye.